So example 3.44 is an interesting 5-mark question. Okay, slowly we'll read the sum and then we will proceed how to solve the problem. A car left 30 minutes later than the scheduled time. Okay, and in order to reach its destination, which is 150 kilometers away, on time, right? He still wants to reach, he started 30 minutes late, but he still wants to reach that destination, which is 150 kilometers away, on time. He had to increase the speed by 25 kilometers per hour from its original speed, from its usual speed. You have to find the usual speed. So, for example, every day if he's starting at 10 a.m., right? He reaches the destination traveling at a speed of say x kilometers per hour, right, at say 10:45 every day, just for example, right? Now on this particular day he's starting 30 minutes later, right? He's starting only at 10:30 a.m. So but he still wants to reach at 10:45, right? So he had to increase the speed by 25 kilometers per hour, right? This is just an example. So this is what this sum means, and you have to find what is his usual speed. So this is the given data, and the distance that he had to travel is 150 kilometers. So if I assume that t1 is the time taken to cover the distance in its usual speed, right? I'll just write it down. So I've just written down t1 is the time taken in hours to cover the distance in usual speed. Now t2 will be the reduced time. Why it is a reduced time? Because I'm still starting at 10:30 but I'm reaching at 10:45. So a trip which takes 45 minutes for me is now taking only 15 minutes because I have increased the speed. So T2 can be called the reduced time, also in hours, right, to reach the destination, the given destination on time. Okay, so what is the difference between that? T1 minus T2 will be 30 minutes, right? Because you're starting 30 minutes late, right? So the time taken in hours is, right? See, if in this example, if you take 45 minus 15 will be 30 minutes because you're starting half an hour late, but you're still reaching it on the same time. So the difference in between the two times will be 30 minutes, right? T1 minus T2 is 30 minutes. 30 minutes is nothing but half hour, right? So this is the given, this is what will be the given equation with which you have to solve for x. So how do we solve that? You should know the formula. Time is equal to distance by speed, right? So in the case of t1, it will be the distance is still 150 divided by speed. Here this is the usual time, right? So it is x, which is the what we have to find out. X is the usual speed. T2 is, the distance is still 150 but the speed is increased by 25 kilometers per hour, and this is equal to 1 by 2. Now I'll take 150 common. 1 by x minus 1 by x plus 25 is equal to 1 by 2. Now just cross multiplying this 2 on the other side, so it becomes 300. Here what is the LCM? X into x plus 25. So here it becomes x plus 25 minus x. I'm just taking the LCM. Is equal to 1. So minus x plus x gets cancelled. So you get 300. So 300 into 25, and I'm taking this to the other side, okay, is equal to x into x plus 25. So 7500 is equal to x squared plus 25x. So shall we write this as a linear equation? X squared plus 25x minus 7500 is equal to 0. Now with this you can solve for x, right? So don't get worried seeing this huge number values of x and this constant here. Okay, so what we should use a sum and product method. What is a sum? What is a product? The sum is minus 7500. Sorry, always write the product first, so it's easier. And the sum is 25. So if you multiply which two numbers, you will get 7500 and still the sum is 25. One thing that quickly comes into my mind is 100 into 75, right? So 75 is into 100 is 7500, and 100 plus 75, 100 plus of minus 75 will be plus 25. So we can split this as x squared plus 100x minus 75x minus 7500 equal to 0. Now let's take x common. X plus 100 minus 75 into x plus 100 is equal to 0. So you get x minus 75 into x plus 100 equal to 0. So from this you know that x is equal to 75 or x is equal to minus 100. But the speed can't be negative, so we'll cancel it out. So the original speed of the car, the usual speed of the car is 75 kilometers per hour, and this is your final answer. Okay, so only to deduce this equation you must have a little bit of understanding. After that it is just solving of a rational expression, like how you did the addition and subtraction of rational expressions. It is exactly the same. So why we are writing it as T1 minus T2, that is one thing you must know, because T2 is the reduced chain. You still have to reach the destination at the same time, so you are increasing the speed. So the time taken to reach that destination in that increased speed is obviously less, right? So that's why the difference T1 minus T2 is 30 minutes as given in the sum. So go through the sum multiple times, and if you still have doubts, you can always get back.